Okay, so I'm going to finish up 11.3 here. So now we're on question 11. They give us this picture. They want us to figure out x, y, and z. Here's a bigger diagram. So this again is number 11. So figure out x, y, and z. Well, notice they tell us A, B, and C, D are parallel, the top and the bottom. This line and this line, A, B, is parallel to C, D. So if the top and the bottom are parallel, then this has got to be a right angle, just like this one is. So if they're both right angles, then I can find x pretty easy, right? X is whatever 90 minus 56 is. What is that? 34 degrees. So I got x. Okay, now I can get y, because y is part of a triangle that makes 180. So 180, take away 90, right, this other 90, and take away 34, whatever x is. That'll leave me, what, 56. X has got to, or y's got to be 56 to make 180 in that triangle. Now, final side z. How are we going to get z? Oh, we got 42 and 56 in that triangle. So z will be 180 minus 42 minus 56. Z will be, I'm going to use my calculator, 180 minus 42 minus 56, 82 degrees. There we go for number 11. Now number 12 gives us this kind of scenario, trying to find x and y. So how are we going to get y here? Well, y, remember, is part of a triangle, totals 180. So it's 180 minus 68 minus 46. So calculator, I'm getting 66. So there's, oh, that's y. That's not x. That's y, 66. Now how are we going to get x? Well, x and y are one side of a straight line. So they have to total 180. So x then is 180 minus 66, which is what? It is 114. So x has to be 114. The measure of an exterior angle of any triangle. So this came out 114. Notice that 114 is what these are added up. They make 114, don't they? So the measure of an exterior, an outside angle of a triangle. See how x is the outside angle of the triangle? It's not one of the three inside angles. It's what's called an exterior angle, an outside angle. The outside angle of a triangle equals what? The sum of the measures of the two remote interior angles. It was these two added up. Right? It always will be. Because, why? Because this side is found by 180 minus those two, and then this side is 180 minus that, so it goes back to those two. That's how that works. All right, on to number 13. They want us to find all the angles there. Let's go to this diagram. So we know this one is 99 because those two are diagonal. See how they're diagonally across from each other? If you fill in these two lines, they're diagonally across. Okay, and same thing here. These are diagonal, so this has got to be 124. Diagonal angles are called vertical angles. They're always equal. All right, and now what else can we do? We need to do something to do like corresponding or something like that. Let's see, what is going to be corresponding angles here? Oh, we can do this one because 124, subtract from 180, right? So this one's got to be 180 minus 124 because these two are one side of a straight line, so they have to total 180. So that one's going to be 56. There we go, 56. Now, notice from this intersection to this intersection, upper left corner, upper left corner. Those have to be the same. This has to be 56 also. They're called corresponding. They're both in the same position of the two intersections, upper left, upper left. Okay, so now we're rolling. Now how do we get this part here? Well, these three make one side of a straight line, which always holds 180. So 180 minus 56 minus 99, I'm going to use my calculator, I'm getting 25 degrees. Okay, now this one down here has got to be 25 because it's diagonally across. This one over here has got to be 56 because it's diagonally across. This one here has got to be 56 because it's diagonally across. All right, what do we got left to find here now? Oh, we can get angle 9 because this, the 25, the 56, and the 9 have to make 180 because they're in a triangle. So 180 minus 25 minus 56. What is that? I'm getting 99, so that's got to be 99, and the one diagonally across, it's got to be 99 as well. Look at that, we found them all. All right, that's number 13. 14. Okay, it's going to be similar. If this is 135, then we can find this one, 180 minus 135, 45. And now we can find x because it's going to be 180 minus the 62 minus the 45, right? Because a triangle has to total 180. So minus 62 minus 45, 73. So there we go. We found x on part A. Let's go to part B. This is 90, and this is 63. So x is 180 again, minus 90 minus 63. What's that going to be? 27. 27. Part C. A little tricky here. So this has to be 180 minus x minus 58, doesn't it? This right here. Because, minus 58 minus x is a triangle holds 180. Okay, great. So what? And then these two together make one side of a straight line, so they have to add up to be 180. So that means that 2x and the other one we just got, the 180 minus x minus 58, they must add up to equal 180 because they're one side of a straight line. So now we can solve that little equation for x. 2x minus 1x leaves 1x. 180 minus 58, let's subtract that. You get 122 is 180. And then finish solving for x. Subtract the 122. Gone. Whoop. Doesn't cancel over here. It subtracts. So x equals 58. That was a tricky one. So x must be 58. All right, how about this part D here? So this is 67 degrees here. And see that right angle there? So this one must be 90 minus 67 because the two together make 90. So what is that one going to be? It's going to be 23 degrees up there. Okay, and now we can find x because I'm kind of running out of room here. This x here must be 180 because it's part of a triangle minus the other two angles, minus 23 minus 90, right? Because this one's a 90 and this one's a 23. So what is that? 67. X must be 67 degrees. There we go. Number 15. An angle measures 6 degrees more than 3 times 6 degrees more than 13 times the measure of its complementary angle. Okay. That's interesting. An angle measures. That's the same thing as saying is. An angle is x is 6 more than what? 13 times its complement. What's its complement? 90 minus x. Let me help with that real quick. Remember, when they say, if I, what is an angle's, so you have an angle, and then that angle's complement. an angle and the angle's complement. How's that work? Well, if you have, that means, complement means adds to 90, right? Like supplement means add to 180, complement means adds to 90. So if this was like 20, then this would be 70, right? Or if this was 30, this would be 60. So how do you get that 70? You take 90 minus 20. So if this is x, this is 90 minus x, isn't it? So that's why it's 90 minus x. That's its complement. So we get this little equation here. This little equation which says x equals 6 plus 13 times its complement, right? The angle is, it measures, it is 6 more than 13 times its complement. So x is 6 more than, distribute that 13. 13 times 90. What am I getting? 1170 minus 13x. Okay, so what do you do when you have x's on both sides? Do the opposite of one of them. Add 13x to both sides. So this will be 14x, and 6 plus 1170 is 1176. And last step to solve for x, divide by 14. And I'm getting x equals 84. 84 degrees. That's a tricky one. Okay. So now if you can kind of read number 16 there, if x degrees and 15x plus 52 degrees are measures of supplementary angles, what is the measure of each? Okay, so they are supplementary angles. So we need to do a little bit of algebra there. Let me go to a fresh screen here. So number 16, x and 15x plus 52 are supplementary. So that means x plus 15x plus 52 is equal to 180. X and 15x is 16x. How do we finish getting x alone? Subtract 52. 16x is 128. Last step, divide by 16. X is 8. So we got x. So x is 8. And what's the other angle? Well, the other angle is supplementary, so it's 180 minus 8 degrees. And so that's 172 degrees. So there it is. So it's 8 and 172. Down here on number 17, determine the measure of an angle whose measure is, so x is 1/2 of its complement. Well, we just did complement right here. 90 minus x, right? So x is, now you got to multiply this half. Half of 90 is 45 minus a half x. Actually, you know what? Let me change the game plan. I mean, that's true, but there's an easier way. So the measure, the angle is 1/2 of its complement, 90 minus x. Easiest thing to do with fractions is just get them out of there right away. So I'm just going to multiply this side by 2 and multiply this side by 2. It cancels that out, so you get 2x, and then you just get 90 minus x. You don't have to worry about the fraction anymore. I multiplied both sides by 2. Whenever you multiply the front of a fraction, the front of a parenthesis by a number, that takes care of it. You don't have to go in the parenthesis. I don't have to multiply 2 in here or here, because whatever you do to the front of a parenthesis will eventually distribute in. You've done it to everything. So that takes care of it, just multiplying 2 on both sides. Cancels it out. And so now how do we finish solving for x here? Add the x to both sides. That's gone. Bring this down. That's 3x is 90. Last step to get x alone. Divide by 3. X is 30. So I got the angle. That's pretty challenging there. Okay, number 18. Find the measure of each of the interior angles of a regular 12-sided polygon. Let me get rid of this stuff here. A regular 12-sided polygon. Okay, so now to find the measure of each interior angle in a regular, remember how this works, in a regular 12-sided polygon. So there was a formula for that, and it was n minus 2 times 180 over n. That's the angle inside of a regular polygon. So for 12 sides, we just plug in a 12. So just plug in a 12 there and there. So it's going to be 12 minus 2 times 180 all over 12. Hit the buttons on your calculator. And I'm getting 150. 150 degrees on that one. There we go. That's the measure of each angle. All right, number 19. So they're telling us, okay, so we got 39. They want all the other angles. So they want WXZ, which is this one. And they want, so let's do that one first. How do we find, well, this one's got to be 90. Because that has to make 180 there, and this other side's 90. So that's 180. And so now we can find this side. It's got to be 180 minus 90 minus 39, which is 90 minus 39. What is that? 51. So that one's 51. And then ZXY. This one, how are we going to do that? Oh, see this right angle here. These two have to total 90, don't they? So this one's got to be 90 minus that last one we found, 51, which is what? 39? Yeah, to make 90 there. 39. That was tricky. Okay, and then finally XYZ, which is which one? XYZ. This one, XYZ. So that one there has got to be 180, because the triangle holds 180, minus 90, this 90, minus 39, because that's that other one. So what does that equal? Well, that's back to the 51, isn't it? Yeah, 51, there we go. It says if, now they're wanting me, now notice these two came out the same, huh? So they're saying if ZWX, which one is ZWX? Oh, this one. ZWX, if that one was A, if you called that one A, what would XYZ be? What would XYZ be? XYZ is the final one. So that's 39, and there's XYZ. Notice 39 and 51. What happened in our problem we just did? Let's see. Okay, follow this logic. In the problem we just did, they're saying if you called angle ZWX, which is this one right here, the 39, which was 39. If you called it by the name A, it's just given it a new name, instead of 39 degrees, it's A. What would XYZ be? Well, what did XYZ come out to be? 51 when that started at 39. What's the relationship between 51 and 39? 51 and 39 total 90. They're complementary, which means the one you start with and the XYZ are complementary. So if you called it A, it would be 90 minus A. Right? That's complementary. Don't let them fool you with A minus 90. Right? If this one's A, then the other one has to be 90 minus A. There we go. So number 20 gives this picture of, here we go, that little, they want us to find, they said this is a regular, what is it? Regular octagon. And we want to find that angle that's sticking out. So if it's a regular octagon, this is a regular octagon, this is number 20 here, we can figure out each of the angles in a regular octagon using the formula. The angles are n minus 2 times 180 over n. So if the thing has octagon, 8 sides, 8 angles, plug in 8. Okay. And I'm getting 135 degrees. So that means that all the angles, this one is 135, this one is 135, this one is 135, etc. All the angles are 135. Okay, great. What does that mean? Well, that means I can find this one and this one, right? This one must be 180 minus 135 because together they make one side of a straight line. And so what's that? 45 degrees. So both of these must be 45, 45. Okay, great. So now can I find the final angle 1 that they want? Yeah, angle 1 must be 180, because a triangle holds 180, minus 45 minus 45. In other words, it must be 90. That's kind of a tricky little problem there. It must be 90. So we go back to answer that one. And now, finally, problem 21. Home plate. And they want us to find the other two congruent angles, right? 3 right angles and 2 other congruent, which means equal angles. Find the measure of the 2 congruent angles, the measure of each congruent angle. So they want me to find this and this. So this is 90, this is 90, and this is 90. Well, what do we know about pentagons or any regular polygon? We can break them into triangles, right? We can just take any point on the edge. Don't start in the middle like that. Take any point on the edge, like say this, and break it into triangles like that. So we have 1, 2, 3 triangles. So the total degrees must be 3 times 180, which is what, 540? So there's 540 total degrees in there. Okay, great. Now what? Well, 540 total degrees. I know this is 90, this is 90, and this is 90. So that leaves 540 minus 90 minus 90 minus 90, which I think leaves 270. Right? Right? And now that means these two must leave these two must be a total of 270 degrees. So each, and they're the same, right? They're congruent. So each one is whatever half of 270 is, 135 degrees. Each of those must be 135 degrees. There we go.